So now that we know what makes a function, let's talk about some notation that we use and do some examples. So this is the notation we're going to use, y equals f of x. So that's function notation. And we read it as f is a function of x or f of x. Okay, so f is just the name of the function. Right here, f, the name of the function. That's all it is. X is the domain or the independent variable. You can think of it as the input. And then f of x, or y, is the output or the range. So what you want to think about when you read this notation, y equals f of x, is that is not multiplication. Okay, so you're not multiplying x by something. You're evaluating a function or a rule at a particular input. So here's an example. Here's a function. F of x is 2x squared minus 3x plus 4. So anytime you plug something in, you're going to square it, you're going to do negative 3 times it, you're going to add 4, okay? So this says find f of negative 2. So to find f of negative 2, you need to plug negative 2 in to all of the x's. So the input is going to be negative 2. And then we're just going to put this in our calculator and see what we get, okay? So 2 times 4 plus 6 plus 4 is 18, okay? So make sure you're using the parentheses around your negative 2. It's important that the x gets parentheses around it. Okay, so now in this second example, it wants x plus 1 to be our input. So when you're thinking of f of x, remember it's 2 times something squared minus 3 times something plus 4. So that something is going to be x plus 1. So this would look like 2 times x plus 1 squared minus 3 times x plus 1 plus 4. And again, if you need to simplify this, you're going to have to do some algebra. And so what you want to think about is to do x plus 1 squared, that's x plus 1 times x plus 1. So you're going to use that distributive property. Same thing here for this 3 is going to go down to both of those terms. So minus 3x minus 3 plus 4, okay? So x plus 1 times x plus 1, you could FOIL that, or you can think about doing the distributive property. So x times x makes x squared, x times 1 makes x, 1 times x makes x, and 1 times 1 makes 1. And then again, this 2 goes with every term inside of there. So that's 2x squared plus 2x plus 2x plus 2 minus 3x minus 3 plus 4. And now combine like terms. So we have 2x squareds. We have 2x minus 3x. So 2x plus 2x makes 4x, minus 3x makes plus 1x. And then we have 2 minus 3 plus 4 makes 3. So when I do f of x plus 1, I end up with 2x squared plus x plus 3. So remember, you're replacing that input, that placeholder, that independent variable with whatever's inside the parentheses. So we can do it with an equation. We can do it with a table. This says use the table of values to evaluate g of 0 and g of 6. So again, 0 and 6 are inside the parentheses, so they're the inputs, they're the x values. So we're going to go to 0 and see what it spits out. So at 0, the table spits out 6.1, right there. And then we're going to go to 6, and we're going to see what it spits out. Well, at 6, the table spits out 9.7. Okay, the last one says find the values of x such that g of x equals 9.3. So now this 9.3 is an output. So in my table, I'm looking in the output column or the output row for 9.3. And I find it right here when x is 2. I might find it in multiple places, right? It's okay for lots of inputs to give me the same output. So if I had found 9.3 in another place, I might have multiple answers for what my x is. Okay, so we did it with an equation, we did it with a table. Let's do it with a word problem. The number of unread emails in Anthony's account is 132. This number grows by 15 unread emails a day. the function n of t equals 132 plus 15t represents the relationship between the number of emails, n, and the time t measured in days. Find n of 14. Okay, so n of t, this 14 is the input, and so that means I'm going to put t equals 14 into the equation. So n of 14 is going to be 132 plus 15 times 14. So just put that in your calculator. 132 plus 15 times 14. And you get 132 plus 210, which is 342. So n of 14 is 342. Remember, 14 was my input. That's my number of days. So after 14 days, he has 342 unread emails. If Anthony's account has 282 unread emails, how many days did he not read his emails? So now we have 282. That's my output, and I'm looking for the time t. So I'm going to say 282 is 132 plus 15t, and I'm going to solve for t. So this is what we practiced back in linear equations. So subtract 132 from both sides. 150 is 15t. Divide both sides by 15, and I get t equals 10. So he didn't read his emails for 10 days. If he has 282 unread emails, that means he did not read his emails for 10 days. Okay, so we did equation, we did table, we did sort of a word problem with an equation in it. Now let's do a graph. So remember, the horizontal axis is your x values. The vertical axis is your y values, or your outputs. And so the first problem says evaluate f of 3. So since 3 is inside the parentheses, it's an input, it's an x value. And what we're doing is we're going to x equals 3 and we're looking for the point on the graph. And so the point that we found is 3, 4. We knew the input was 3, we were looking for the output. So f of 3 equals 4. When I go to x equals 3, the graph spits out the point 3, 4. The y value is 4 there. Okay, now it says solve f of x equals 1. The 1 is my output, or my y value, and I'm looking for the x's. So on this graph, I want to go to y equals 1. Remember, y equals 1 is very long, right? It's a whole horizontal point. And so I see that y is 1 at this point on the graph, and also over here at this point on the graph. So y is 1 at 2 places, 0, 1, and 2, 1. So there are 2 x values that make this true. X equals 0 or x equals 2. Because f of 0 is 1, that's the point on my graph, and f of 2 is 1, another point on my graph. So when the number is inside the parentheses, you go to that x value and you look for the 1 point on the graph. If the number is after the equals, or it's the output, you go to that y value and you look for all the possible places where the graph, all the x values, where the graph touches that y value.